Welcome back to Voodoo Family Travels. I'm Greg.
And I'm Val. Please join us today as we go to the Hoover Dam.
As we arrive at the Hoover Dam, there is paid parking in a garage for $10 on the Nevada side. There are also free parking lots on the Arizona side. Tours available are the complete dam tour for $30, which includes the power plant visitor center and a short movie. The power plant tour for $15 and just the visitor center for $10. Both of these include the movie as well.
The Hoover Dam is a concrete arch gravity dam in the Black Canyon of the Colorado River on the border of Nevada and Arizona. It was constructed between 1931 and 1936 during the Great Depression. It was a massive effort that employed thousands of workers. Over 100 lives were lost during construction. We're heading down into the Hoover Dam tour. So we took an elevator down 500 something feet, about 64 stories. So we get down into the dam, 54 stories. Yeah. Yes.
All right, so first of all, can everyone hear me okay? You guys in the back, you're good? All right, perfect. So welcome once again to Hoover Dam. This is a map of the Hoover Dam site. And this is where we are. We are standing inside of a diversion tunnel. So when they began to build the dam, they needed to find a way to move the river from the construction site. And they did that by building 4 diversion tunnels. There's 2 on the Arizona side and 2 on the Nevada side. They're 50 feet in diameter, about 3/4 of a mile long, and it took them almost 2 years to completely blast out all 4 tunnels. Once the tunnels were finished, they had to figure out how they were going to push the river into the tunnels, and they did that by building coffer dams. A coffer dam creates a dry area where they can do construction. So they built bridges across the river, and about every 15 seconds, a truck would drive across and dump all that debris from blasting out the tunnels into the river. That's how they started to build up these 2 coffer dams. So one is built upstream. This one pushes the river into the tunnels. The other is built downstream. This one keeps the river from flowing back into the construction site. So once those coffer dams were finished, they drained the site and they removed 135 feet of loose rock, debris, and silt to get down to the bedrock, which is the dam's foundation. That took about 7 months. June 6, 1933, they were ready to begin building the dam. They had buckets carrying 8 cubic yards of concrete, which is 16 tons. Those were delivered every 78 seconds. They did it 24 hours a day, 7 days a week for 2 years. Once they were finished building the dam, then they were ready to begin filling up the lake. And they did that by closing off 3 of the diversion tunnels by lowering heavy steel gates. They did leave 1 tunnel open, that way the river could continue to flow back downstream. So once the water was high enough, they did close off that last diversion tunnel. They blasted out the lower coffer dam, that way the river moves more freely as it travels downstream. But that upper coffer dam, it still remains underwater today. It took a total of 6.5 years to completely fill up the lake. So how do we get water from one side of the dam to the other? Intake towers, and there are 4. There's 2 on the Arizona side, 2 on the Nevada side. They're 395 feet tall, and they sit up on 250-foot rock ledges. So the water flows down through them into 30-foot diameter penstock pipes like this one that you can see out the window. So you may feel the floor vibrating beneath your feet, and that is up to 96,000 gallons of water per second flowing through the pipe. That would be enough water to fill an Olympic-sized swimming pool in just 7 seconds. Then the water flows down into smaller 13-foot diameter pipes that leads to the generators spinning the turbines, and then it flows back down the river. Last thing I'm going to tell you about are the spillways. They're on either side of the dam, one on the Arizona side, one on the Nevada side. And they were built to keep floodwaters from going over the top of the dam. We've used them twice. Once in 1941 for testing. So when they first filled up the lake, they overfilled it on purpose. Thank goodness they worked, because in 1983 we did have a flood. There was a heavy snow melt up in the Rocky Mountains. That's where all our water comes from. And all the conditions were just right that year. So here's a picture from the flood of 1983. This is the dam right back there. The water ended up cresting within 7 feet from the top of the dam. That is way too close. When this flood was occurring, water was going over the spillways for 63 days in a row. That's about the equivalent of 2 Niagara Falls every single day. So the water goes into the spillways, through the tunnels, around the dam, and then safely back into the river. All right, the next stop on our tour is going to be the Nevada wing of the power plant. I'm going to be the first one out. You guys are going to follow me. Just to let you know really quick, I know as you're standing in here, you don't feel this floor vibrating. There's 4 of these huge pipes, and they all feed different generators. There's only one generator running on in the power plant on the Nevada side, so there's not a lot of water going through the pipe. Sometimes when you're standing in here, you can definitely feel this floor shaking. It's unmistakable. If you happen to be standing in here when they turn on a generator that pipe feeds, it actually feels like an earthquake. But yeah, there's just not a lot of generators running right now. Usually they turn more on in the afternoon. How much water they need downstream. Downstream is what dictates how many generators are running. So follow me. Welcome to the Nevada wing of the power plant. I would like to direct your attention down the room to the generators. There are 8 that you see here on the Nevada side. We have 9 more on the Arizona side for a total of 17 commercial generators. Each generator stands 70 feet tall, but you can only see the top 30 feet of them. Just one generator can produce up to 130 megawatts of electricity. That's enough to power about 65,000 homes. Look at the first generator and one halfway down, you see a light shining on a 65-foot steel shaft. At the bottom of the shaft is the turbine. The water comes down through those huge penstock pipes into the turbine at about 48 miles an hour, spinning the shaft, which is connected to the rotor housed inside the red drum. If you look right below us, this is the armature of the rotor that came out of N3. That's why it looks like there's a generator missing. The rotor is made up of 40 electromagnets, each magnet weighing 4 tons. The armature below us, all those magnets have been removed for maintenance, along with over 7,000 steel plates.
And you can see some of these steel plates on the floor below us sitting on those pallets. They are getting ready to reassemble this rotor. Sitting around the rotor inside the red drum is the stator, and that's about 5 miles of stationary copper coil. The rotor spins at 180 revolutions per minute. So as those magnets spin around the copper coil, that is how they produce electricity here at Hoover Dam. If the lights on top of the generators are on, they are in operation. Next, if you look down at the power plant floor closer to us, you will see a small rust-colored Pelton water wheel enclosed within a fence. This was the first generator put into operation September 11th, 1936. This is very important because it's where we get all our in-house power here at the dam, such as for lights, elevators, and machinery. We do have one just like this on the Arizona side, so one of these generators is always running. These smaller generators produce 2.4 megawatts of electricity. Now, if you look above the generators towards the ceiling, you will see 2 P&H bridge cranes going across the room. First one has our American flag hanging from it, and its sister is way down there at the end of the bay. These cranes are original, run on tracks, and can be moved the entire length of the power plant. It's what they use to install the generators, and they're used for maintenance. One crane can lift 300 tons. To put this into perspective, the Statue of Liberty in New York weighs 225 tons. One crane could pick her up, no problem. But sometimes that's not enough for what we need here at the dam. They must be used together to form a super crane, which can lift 600 tons. Because when they do have to lift out one of these rotors from the generator, fully assembled, they can weigh over 580 tons. Now, if you look down at the floor around your feet, you will be looking at the terrazzo marble that was put in place in 1937 by the Martina family with visitors in mind. The marble flooring covers 121,000 square feet of the power plant floor. Also on the floor you see symbols. They were created by American artist Alan Tupper Drew, who wanted to bring Southwest Native American designs into the project. The one I'm standing next to shows an electrical outlet which represents power. And the circular one behind the rest of you shows the movement of the water flowing through the turbine.
So here at this level, there's 200 feet of the dam below us. In just a moment, we're going to walk down this tunnel. Once you get inside this tunnel, you're going to be inside the dam. We're going to go down about 350 feet to another elevator. So when you're standing at that elevator, there's 100 feet of the dam between us and the lake. The top of the lake is about 330 feet above our heads on the other side. Okay? So we're going to get started. Once we get down to that elevator, I'm going to talk to you for a few more minutes, explain to you what's going to happen when we get inside these inspection tunnels. Okay? So come with me.
We're heading into the tunnel inside the dam. Yes, now we're inside inspection tunnel in the dam. Here's a view from inside the dam. Bridge up there. View from the inspection tunnel in the dam.
On the outside, on each side. When they built Hoover Dam, definitely thinking about earthquakes. We are third in the nation for earthquake activity, although most of them that we get, they're pretty small. The biggest recorded earthquake here was back in the 1950s. It was a 5.2. But the dam is not attached to the canyon in any way. The sheer weight of it holds it down on its foundation. It goes inside the canyon walls on each side about 75 feet, and they put a cement grout all around it. They call it a grout curtain. That way, if we have an earthquake, the whole dam can move and shift. Now, it's not the power plant, it's not any of the other buildings, that's just the dam itself. But they did build it to withstand right around an 8.6 earthquake, which that's pretty huge. So if we had an earthquake in the next few minutes, this is definitely where you'd want to be. All right, then right above that, you're going to see a couple of black panels on the wall. Lots and lots of these in the tunnels inside the dam. It was called the Carlson Metering Station, and they put a picture of what used to be behind it. And you're going to see all these terminals in rows. So they have 3 different types of gauges that were attached to wires that were attached to these terminals. As they were pouring the concrete, they would place these gauges in a block. Then they had a tool that they placed on the terminal, and they could test pressure, temperature, and strain in different areas of the dam to see how it was cooling and curing. It let them know when they could place another block in a column. In the movie that you watched, they talked about how they ran that ice cold water through for 72 hours. Well, not all the blocks were the same size, and they also poured the concrete all year round. So maybe they didn't have to wait 72 hours. Maybe they could do it in 52 hours. So it was a real game changer in the building of the dam, and it was a very, very cutting edge technology for back in those days. So you'll see those 2 things, then you're going to turn a corner, you're going to go down just a little bit farther, and you're going to see what we call the stairway to heaven. It's a staircase that goes from the bottom of the dam up to the top, 717 steps. It's very, very steep. It's about a 55-degree angle, so it's only about 2 degrees off the ladder. And just do the same thing, go down there, get a look at everything, take your pictures.
This is the staircase. That's the stairway to hell. All the way down to the bottom of the dam. And this is the one that goes all the way into the top of the dam. That's heavy. That's heavy. That's the other one hell. No.
Yes. They don't. We do actually, there are some tour guides here. I think Alan's actually one of them. The tour guides.
A few final bits of information about the dam. The height is 726 feet. The length is 1,244 feet. The width at the top of the dam is 45 feet. The width at the bottom of the dam is 660 feet. And the volume is 3,250,000 cubic yards.
Thank y'all for watching Voodoo Family Travels. I'm Greg.
And I'm Val. See you again soon.